Here is a comparison that seems impossible. Method A beats method B in an easy group, and A beats B again in a hard group. Combine the groups, and B wins by a huge margin. Nothing was misadded. The two comparisons simply used different weights. Let's reconstruct the flip. In the easy group, A succeeds 9 times out of 10, or 90%. B succeeds 80 times out of 100, or 80%. A is ahead. In the hard group, A succeeds 1 time out of 100, or 1%. B succeeds 0 times out of 10, or 0%. A is still ahead. The within-group trend is consistent. Now pool the groups. Pooling means adding successes and adding trials. A becomes 10 successes out of 110 trials, 9.1%. B becomes 80 successes out of 110 trials, 72.7%. The winner has reversed. An equal average of the 4 displayed percentages would answer a different question, because the 4 groups did not contribute equally many observations. Look at where the observations came from. A has 100 of its 110 trials in the hard group. B has 100 of its 110 trials in the easy group. So A's pooled rate is pulled toward the hard group result, while B's is pulled toward the easy group result. The denominator is not bookkeeping. It is the weight each subgroup gets in the combined number. For any pooled rate, multiply each subgroup rate by its number of observations, add those contributions, and divide by the total observations. If A is at least as high as B in every subgroup, and both methods have the same subgroup weights, the pooled ordering cannot flip. A reversal needs the mixtures to differ. That is the mathematical core of the paradox. This pattern is called Simpson's paradox, or a Simpson reversal. An association seen inside groups disappears or changes direction when the groups are combined. The word paradox describes the surprise, not a failure of arithmetic. It also does not tell you which comparison is causal. The subgroup, the process that assigned people to groups, and the question you actually care about still matter. The classic Berkeley admissions data make the warning concrete. Across 6 departments in 1973, the pooled admission rate was 50.3% for men and 30.4% for women. But women's rate was higher in 4 of those 6 departments. The departments had very different selectivity, and the application mix was different across them. So the aggregate gap is descriptive evidence about that table, not a standalone causal verdict about admissions decisions. Before pooling, ask 4 questions. What is the unit being counted? What is the denominator for the rate? How much weight does each subgroup contribute? And is there a subgroup or context that changes the comparison? These questions do not force one answer. They stop you from silently changing the question. Combining groups can reverse a trend because a pooled number is a weighted mixture, not a vote where every subgroup counts once. The pooled result can be correct for the combined population and still be the wrong summary for a within-group decision. Keep the strata visible, inspect their weights, and only then choose the comparison you mean.